happy Wednesday afternoon, everyone. Thanks so much for joining the stream. For those guys who do not know me, my name is Doc V. I'm a meteorologist for the weather company, which is now part of IBM. If you guys aren't familiar with what the weather company is, well, we have consumer platforms. That's your Weather Channel app on your iPhone or Android device, or also your weather.com on the internet. That being said, the views that I'm going to express today in this stream are not reflect those of my employer, but are just meant for educational purposes. We're just here to kind of shoot the breeze, talk about what's going on in the weather, and I appreciate that you guys have joined the stream today. So we're going to make this pretty informal today. We're going to have a good time, hang out. I see that there's already some action in the chat there. Thanks for joining Tree Cutter and Lex, Call of Duty Buddy. I do want to say that the introduction loading up into the screen, that hurricane was in fact major hurricane Laura before it made landfall. Pretty bad hurricane for the 2020 season. One of 9 landfalling tropical cyclones of the season, which ties the record for the most landfalling storms in a given season, which was set back in 1916. So, guys, it's September 23rd. We're here hanging out. It's hurricane season is continuing, and we've had 9 landfalling storms. We've tied the record for the most named storms to hit the continental U.S., and it's probably a good chance that we're going to break that this year, right? The way that 2020 has been going, a year of pandemic, a year of forest fires outbreaking, the year of a record-setting pace of the Atlantic hurricane season, it's been quite an interesting year. And for those who have been impacted by any of these events, my thoughts go out to all of you guys. It's been a tough one. So I do want to say though, guys, thanks again for joining. For people who are new to Twitch, because I'm still new, I'm still learning the best way to get this information out there, to get the interaction between myself and you. If you guys want to ask any weather questions, you have to follow me on Twitch to get access, which is free, to the chat, okay? And the purpose of these streams are to be able to interact with one another, right? On Twitter, I do put out a lot of information on Twitter, but I don't see everyone's questions. I just don't get the chance to. And also, there's something with Twitter where if you're not verified and you ask a question, I never see it. So I have to dig through my old tweets to actually go through them to find some of the questions that you guys have. So unfortunately, I don't get to see it all. So that's why we're here today. Ask away your questions. So I do want to say right now, there is one positive thing, or breath of fresh air, some news to share. And I'm going to share my screen here and show you guys the current view of what's going on in the tropics. And guys, literally, there's no hurricanes active. When was the last time that we saw not one active hurricane? We still have the remnants essentially the post-tropical reports of Tropical Storm Beta and our old hurricane friend Teddy there, currently pushing across parts of Canada. But the tropics are quiet right now, guys, which is awesome for everyone who's been tracking this season, has been following this very closely. I can tell you right now, my friends at the National Hurricane Center have been, they're tired. They've been worked pretty thin right now because of all the activity that's been going on. So this is what I like to call an intra-seasonal lull in the activity. We're not seeing new storms spin up within at least the next 7 days, potentially the next 10 days. So these are all things that we can get to a little bit more. If you guys want to get more into the tropics, we could talk about some extratropical things. My buddy Lex in the chat here asking some questions about fantasy football. If you guys are not aware, myself and some other meteorologist friends here, we have not a company, but like a little hobby called the Fantasy Football Weather Guys, where we take on your questions about fantasy football and bring in the weather component. So I see Alexis is asking the question about who would you rather play, Joshua Kelly or Devin Singletary for your running back too if you're playing Eckler already this week against Carolina. I'd probably go with Joshua Kelly. Singletary, he does get that, he does get work. He gets half the volume in Buffalo. But I think now with Zach Moss in the picture, Singletary's value is capped, where I think Joshua Kelly has a little bit more upside. So that's enough for the fantasy football banter. But let's get into, I guess, some weather here. Again, guys, any questions, please enter them to the chat. If you're having issues with entering information to your chat, all you have to do is follow me on Twitch, twitch.tv/MJVentures, and you'll be able to see the chat and get into some questions there. So let's start off with some things that I looked at. I put on some things on Twitter here. I'm going to bring up my feed, and I am going to bring up a tweet that I guess sparked some controversy in the weather world. Here we go. So this was back on September 20th, a few days ago, and this was talking about something that I studied in graduate school. These are called Kelvin waves, all right? There's a lot of different types of Kelvin waves that we can talk about. There's Kelvin waves in the atmosphere, where we have essentially the large tropospheric, stratospheric Kelvin waves that I focus on. They can couple with convection, meaning they can be active thunderstorm-wise or suppressed depending on the phase. There's Kelvin waves in the ocean. A lot of when you often hear about Kelvin waves in the ocean, it's often these waves in the ocean that can facilitate or break down particular phases of the El Nino and Southern Oscillation. So when you ever hear of a downwelling Kelvin wave in the ocean, you can think of it as a forcing mechanism in the ocean for bringing on El Nino. But there's also upwelling oceanic Kelvin waves, and these are the things that can actually enhance your La Nina state as well, depending on where they're located or positioned in the Pacific Basin. But they can happen anywhere. It just depends on where there's a thermocline in the ocean. You could have them in the Atlantic Ocean. You could have them in the Indian Ocean. So these are all things that these are all some of the more common oceanic or Kelvin wave terminology that we'll often throw around on Twitter. But there's also things like Kelvin Helmholtz waves, which I can show you a really awesome shot of that after this particular idea that I want to express here. But back a few days ago, I was tracking this particular atmospheric Kelvin wave and noticing that there is this upper level suppressed Kelvin wave coming through, right? And I can show you what the image I had to show here is. So wherever you see the oranges or the yellows, essentially this is the suppressed phase of a Kelvin wave that's coming from the Pacific Ocean, and it's predicted to move across the Atlantic Basin in Africa in the next 7 days or so. What these suppressed Kelvin waves do is they actually can really cause the environment to change over the tropical Atlantic Basin. They can bring in what this is known as an unfavorable environment that for developing tropical cyclones. We can often see enhanced vertical wind shear after these suppressed Kelvin waves pass. We can often see large-scale subsidence, so the atmosphere dries out, and we can actually see upper tropospheric troughs set up over the western subtropical Atlantic that brings in more mid-latitude dry air. And all these things combined can really limit the prospects for developing tropical cyclones over the Atlantic Basin. And we're watching one of these features come through today. If you guys are interested in tracking these waves, I actually have an old website from the University at Albany back in my graduate school days where I built a tracker. So you can just go to this, I think the website is mikeventures.weebly.com. And if you click on the CCKW/MJO page, you can see this updated plot here, which is Kelvin filtered upper level winds, essentially this parameter called velocity potential. And you can loop this across, and you can see how there's an active phase by the blue that just passed. We had some bursts in activity recently, right? We had 3 tropical storms set up, and I think we had Alpha and Beta, and also there was Teddy out there. And now we're getting this opposite phase of the Kelvin wave coming through. And that's essentially an indication that the Atlantic hurricane season is going to move into more of like a quiet period. Now, you can still get developing tropical cyclones when these Kelvin waves come through these suppressed phases, but the probability of those are lower. And often the storms that do develop during these types of suppressed Kelvin wave passages are weak. they tend to struggle because there's enhanced shear, there's dry air. Now, we typically can see, if a storm does manage to spin up as these suppressed Kelvin waves come through, typically what happens if the models are aggressive with the intensification of them, once they kind of move outside of the tropical belt, like let's say north of 20 degrees north of latitude, and then move into the subtropics, that's where you can start to see the intensification usually take place. Again, this stuff was, I kind of talked about this stuff in my PhD dissertation when I was at the University of Albany writing that, and I do have a section that focuses on these suppressed Kelvin waves and how they interact with tropical cyclones. So if you guys are interested in seeing that research, please check out my PhD dissertation that you can find on my my UAlbany website under the publication section. There's a PhD dissertation link there. So anyway, we have this suppressed Kelvin wave coming through. I spoke about this a few days ago, and you can track this in upper level wind fields in a Hofmahler sense. If you guys aren't used to these time longitude plots, essentially time's on the y-axis here going down. So the current time is at the bottom usually with some forecast data there. On the x-axis is longitude. So the Atlantic Basin is pretty much on the right side of this image, and you can just bring your eyes up and down on this right side of the image, and that's pretty much all Atlantic winds. And we're looking at 200 millibar wind anomalies. So wherever you see the warm-colored shading, it's essentially an enhancement to your upper-level westerly winds along the equator. And the blues and purples are your enhanced upper-level easterly winds. Hurricanes like to be they typically develop when the upper-level easterly wind, when the anomaly is an upper-level easterly over the particular location that these waves are developing. So you can see that there was an upper-level easterly feature, the upper-level easterly phase of this Kelvin wave, which coincides with your active Kelvin wave here coming through the Atlantic Basin. Now we're having this upper-level westerly wind phase come into the Kelvin wave, and I have these contours on here so you can see where the Kelvin wave phase is, and you can think of these red contours as the suppressed phase of the Kelvin wave. And essentially here, you can see that this suppressed Kelvin wave brings these westerly wind anomalies at 200 millibars, top of the troposphere, way up into the atmosphere, just below the stratosphere. And you can see how this kind of moves into across the tropical Atlantic and African region. And whenever you get these upper level westerly winds, it's a typically something that enhances your vertical wind shear. You often can open up what's known as a westerly wind duct over the equatorial Atlantic or over Africa, and those upper-level westerly wind ducts actually encourage the propagation of these planetary waves towards the equator. And that's where you get these upper-level troughs that spin up over the subtropical Atlantic and cause shear and subsidence in dry air. So these are all things that these Kelvin waves can really kind of help modify, and you can change the probability of when these types of things happen. But I mean, like this, we're looking at something here that suggests that the Atlantic Basin is going to move into a slightly less favorable environment for developing tropical cyclones, and it's going to cause the Atlantic hurricane frequency to reduce. So we're going to go into a lull, right? We have no Atlantic storms right now. We're seeing that. I can actually show the updated plot here of what this looks like here. So if I bring this a little bit to the screen here and zoom in, here's the latest plot with updated today, September 23rd. And you can see here that we're already getting some upper level westerly winds along the Atlantic Basin. Those are going to continue here for at least 1 week, maybe a little bit more. So this is an indication here again that the atmosphere is shifting from what was a very favorable environment for developing tropical cyclones into one that's not favorable anymore, which is fine. These are things. We call these periods intraseasonal variability, meaning week-to-week variability in the tropics. So it happens all the time. All it does is it shuffles the frequency of developing tropical cyclones on a given week compared to another one. So back in August, if I look at like I want to see if I go back to my Albany website here. And let me see if I can bring up a 90-day plot of those upper-level westerly wind features. And back in like early August, we had another suppressed phase come through by these like yellows and red shadings coming across the Atlantic Basin here. And this is when the Atlantic went into like another quiet state. And I remember it was probably around August 14th or 15th here. This was when a lot of the folks in the community, in the tropical community, started getting concerned about our Atlantic hurricane season, saying, hey, it looked dead. over the Atlantic Basin. There's all these, there's not a whole lot of activity. The one or two storms that we've had were very weak. I think the Atlantic hurricane season is in trouble. All the active calls that are coming through, right? And I was saying, hey guys, I had to like reach out to this server and say, guys, this is an intra-seasonal lull in activity. It doesn't mean the season's going to be a bust here. There's going to be another impressive burst of activity during the latter half of August through the first half of September, and it's going to make for a remarkably active season as you get into the peak. And we saw that. We saw, we've passed the Greek alphabet, right? We've had alpha and beta this past few days. So this is only the second time in history in our Atlantic archives that we've gotten into the Greek alphabet for naming tropical cyclones. If you look at other diagnostics like accumulated cyclone energy, ACE, we are above normal now. We skyrocketed in the recent burst of activity. And if you look at this Hofmüller diagram and you look at this late August, front half of September over the Atlantic Basin in Africa, look at all those upper level anomalous easterly winds, the blues and purples. That is essentially what you're seeing here. If you bring your eyes down with time, there's this eastward propagation of anomalous upper-level easterly winds. This is the active phase of the Madden-Julian oscillation. You can see how it's spatially very robust here. It takes a number of weeks to pass a particular location. This is the MJO. And we're seeing this upper-level westerly phase of the MJO come through right now. That's your suppressed state. Now, there's a lot of issues in these diagnostics because you have things like standing waves that can really kind of cause the picture to get a little bit unclear. But you can definitely point out without filters here where your upper level westerly wind phase of the MJO is by this, west to east propagation of upper level westerly winds. You can see the upper level easterly wind. This is the phase of the MJO as it moves across the Atlantic and African basin, the Atlantic basin, the African continent into the Indian Ocean. This is where the most favorable phase for developing tropical cyclones are. And as it gets over the Indian Ocean there, when the MJO active phase or the upper level easterly wind phase moves over the Indian Ocean, that is the most favorable state for Atlantic hurricanes. These are where we typically see these major hurricanes spin up. And we just, we saw that with Laura. We saw that with other things like Teddy. So we are now looking at a period in time where the upper level westerly wind phase of the MJO is coming back around. And essentially what this means is we're going to move back into that intra-seasonal low. We're not going to see a ton of activity in the next one, maybe 2 weeks. I know that there's some issues, some models, GFS model, there's some ensemble guidance suggesting that we could get a potential tropical cyclone developing over the Western Caribbean in maybe 7 to 10 days. The jury is still out on this storm. And we can kind of focus on that a little bit. But the one point I want to comment here is, don't be fooled if the Atlantic season starts to get quiet again. Okay, if the hurricanes, you might start to go into another period in time where the media stops focusing on the hurricane season. They're like, all right, things are quiet. There's a chance that happens. Okay, with this particular intra-seasonal setup. But I do want to point out, and I put out a tweet here, I think this morning. And it was of the CFS model, which is the American subseasonal model here. Let me bring this up here. There we go. Now I'm actually showing the phase of the MJO in contours, and I'm showing the upper level easterly or westerly phase, and essentially wherever air is rising or sinking in the shading. The blues and purples are essentially the favorable phase for convection in the tropics, thunderstorms, or tropical cyclones, so rising air. And you can see that those are outlined by these black dashed contours. And I want to focus on this event that passed the Atlantic Basin back in early July, this active MJO, which the dashed contours can trace it. We're looking along the entire globe here. All longitudes are on the x-axis. There's a mini map down here so you can see where you are. And take a look at this active MJO past the African Indian Ocean back in late July. It passed across the Pacific Ocean around the middle half of August. And now we're seeing that we saw it pass again the Atlantic Basin in the latter half of August into early September. We had a burst of activity during the front half of July of Atlantic tropical cyclones. We had 5 named storms. We had a secondary burst in activity this past month, right? Most of September has been extremely active, and that's right when this MJO passed across the Atlantic African continent and in the Indian Ocean. And we're seeing this repeating cycle in the atmosphere happen again, right? This model is predicting that we're going to see this same MJO event, the same one that keeps going round and round and round the globe. It's coming back around again, guys, and it's going to pass the Atlantic and African continent probably around the second week of October. And we're moving back into that state again that it's conducive for developing tropical cyclones over the Atlantic basin. So we're looking at another possible period in time where we could see another burst in tropical cyclone activity in the Atlantic basin. It looks like it's going to happen probably sometime in that second week of October and continue through the early part of November. Okay, guys, so you're seeing this signal again, and this has been repeating over the last 2 months. It's a good forecast here. I like what this model is showing. And I'm thinking that if we do go into an intraseasonal lull in activity, people might fall asleep again. So guys, pay attention to the tropics as you move into the latter season of the later part of the Atlantic hurricane season. What typically happens is the waves that coming off Africa and seeds these hurricanes over the Atlantic basin. That type of process starts to end. As we get into late September, those waves that are coming off of Africa are tied to what's called the West African monsoon. And the West African monsoon brings a lot of rainfall to the sub-Saharan zones in Africa, which is really good for agriculture out there. These waves it's a big component of life activity out in Africa during the summertime. There's a starting point and there's an ending point of the West African monsoon. And the starting point is usually sometime in June, and the ending point is usually sometime in September, October, usually September. We're getting to the point in time of the season where the West African monsoon is turning off. So what that means is as we kind of think about what can seed tropical cyclones, these African easterly waves that are tied to the West African monsoon, those start to shut down as you get later in the season. So what this typically spells is we often see the developing hurricane activity of the Atlantic basin shift away from the main development region, which is essentially the area of ocean just to the west of Africa, the northern hump of West Africa, and we see the storms start to develop in the Caribbean Sea and the Gulf of Mexico. And these are what we call these homegrown systems. They can also spin up in the subtropics, depending on the extratropical pattern, but we're going to start to see storms develop more closer to home as we get later into the hurricane season. And I'm looking at this latter half of October as a period in time that we're going to have to pay attention to for some potentially big hurricanes coming to the Caribbean and Gulf of Mexico again. And this is why I think we're going to break the record for landfalling tropical cyclones in a given season. We've tied the record of 1916, and we're going to probably break that here as we get into the latter half of October. If I'm predicting we're going to see another burst in Atlantic hurricane activity. All right. Hey, thanks so much there, Will, for the subscription on Prime. I appreciate that 2-month subscription, 2-tier. Thanks so much, buddy. I appreciate you coming back to the stream and enjoying it here. So, Tree Cutter, it's still hard to believe that in about 2 weeks we've gained 59 ACE, which is about 55% of a typical season. Yeah. So that ACE diagnostic, right? The accumulated cyclone energy, those are that diagnostic really cares about these long-lived, strong hurricanes. You're going to see your ACE diagnostic skewed in favor of seasons that have these big hurricanes that are intense. Cat 3, Cat 4, Cat 5, the ones that last for a number of days. And we saw a number of big hurricanes in the recent week here, right? Teddy was a pretty good ACE builder. Even Paulette was around for a long time. That contributed to the number of ACE in this particular given time, this recent burst in activity. Question is, when will the African West Indian Ocean standing wave break down? That's a good question. So let's take a look at my playpen of products here. And I'll answer that question, and we'll get back to the potential Caribbean system in the Gulf of Mexico, in the Western Caribbean or Gulf of Mexico in the coming week. And I'm going to show you what the CFS standing wave diagnostic tool is showing. So essentially, oh, this is pretty small in the stream. I bring that up, make it larger here. This product here is something that I've developed to kind of identify standing waves in the tropics, right? So the blue shading represents where air is rising. The yellow shading is essentially where air is sinking. This is when I talk about standing waves in the tropics, I'm talking about the rising component. And these are things that vary very slowly in time. They can set up in a given season like fall and persist until the next 1 to 2 years, right? These are things that are very slowly evolving, and the African West Indian Ocean standing wave is something that set up last October. And if you bring your eyes down with time here, it's still there. We've seen some slight eastward shift in the standing wave to more of a central Indian Ocean, but it's still over Africa. It's still over the Indian Ocean. And what's probably going to happen here, as we move into the winter months, we're into La Nina. You can see the atmosphere is responding to La Nina by essentially the yellow and orange shading over the Pacific Ocean here. You can see this is the Pacific Basin. And you can see that this set up back in June, and it's only grown in amplitude today. And this is the atmosphere saying there's subsidence over the Pacific Basin, which is often analogous to a La Nina state. Last year, we saw the opposite, right? Last summer and into winter, we saw there was East Pacific and Central Pacific forcing. This was an Eastern Pacific El Nino that evolved into what's known as a Modoki El Nino as it went into the summer and spring months, and that has shut off ever since. This was one of the biggest signals out here for seasonal forecasters to call for a active Atlantic hurricane season. This is a prime low frequency state for Atlantic hurricanes. So I'm thinking here the African West Indian Ocean or Indian Ocean standing wave is going to be here for at least another few months. And as you move into the later half of winter into next spring, what typically happens is you'll see the blue shading move over the maritime continent and Western Pacific. So it'll take a long time to get there, but it's going to slowly propagate eastward. And we're already starting to see that in these contours here that show the light blues, right? You can kind of see that there's like a west to east type of progression of that contour. So we're starting to see that slow process evolve, and this is what's going to be, our main driver, depending on the stratosphere polar vortex. But this is probably going to be our main tropical driver for our upcoming winter season. So, Tree Cutter, you had a question here. How likely is it that we see another major hurricane or two? I don't think I think it's pretty likely. I mean, like when we're looking at the intraseasonal state in the tropics, like that MJO plot I just showed here, I'm going to bring it up again and kind of just hang out here for a second. When you get this type of MJO that passes the African Indian Ocean continent here, this is a signal that's very favorable for future Atlantic hurricanes and strong hurricanes to that matter. So I think we're going to see, the Atlantic Basin not have a major hurricane for maybe a 2 to 3 week period in time, but I like the prospects for another major hurricane as you get into the latter half of October here. Let me bring my screen up here to the top right. I appreciate the new follow there. Thanks so much, bud. So I see that you have another question. Could you provide another boiled down comparison explanation of MJO and Kelvin waves for this non-weather person? All right, what's up? Thanks for the question, Hayes. So the MJO is this mother of circulation in the tropics. It's a global feature that essentially you can get one area of rising air along the equatorial band. Let's say over the Indian Ocean, there's a lot of rising air that helps organize thunderstorm activity there. And on the other side of the world, like let's say the Atlantic Basin or the Pacific Basin, you have subsidence, so the connection struggles. It's this big circulation feature in the tropics, the MJO, that can really organize or enhance or suppress your tropical rainfall. And due to the enhancement or suppression of tropical rainfall, it can actually play a factor in changing the frequency of developing tropical cyclones over a given basin, depending on where the MJO is. So when the MJO is passing the Atlantic Basin or the Indian Ocean, those are typically the states where we see more Atlantic hurricanes. When the MJO is over the Pacific Basin, like the Central Pacific Basin, that's where we typically see activity quiet down over the Atlantic Basin. And today we're looking at the MJO passing the Pacific Basin right now. So we're probably going to move into a state that is less conducive for developing tropical cyclones over the Atlantic Basin. Kelvin waves are much faster. They are usually smaller scale, and they travel eastward at maybe around 15-20 meters per second along the equator. The MJO is typically slower. It can travel around, and it can slow down to as maybe slow as 5 to 8 meters per second, especially when it moves over locations where convection is prevalent, like over the Indian Ocean this year. It'll slow down quite significantly, and then as it moves across areas that are less conducive for convection, like let's say the Pacific Basin, it speeds up. In my professional opinion, the separation between Kelvin waves and the MJO, they shouldn't be happening anymore. I think that the MJO is in fact a form of a Kelvin wave. We're just seeing it slow down over areas where convection is prominent, and it speeds up over areas where convection is less prominent. And that, if you actually try to filter for these waves, right, you can do something called wave number frequency filtering. It's a spectral filtering technique that we use as meteorologists to kind of understand what these waves are doing. That's how I get these contours on these maps, these black contours. It's through spectral filtering. If you filter rainfall or some kind of proxy for convection like outgoing long wave radiation, you're going to see a gap in spectral power between the Kelvin wave and the MJO band. That spectral gap does not exist if you filter winds. Okay, so in literature, in our meteorology journals, everyone said that the MJO and Kelvin waves are different because there's a gap in spectral power between the MJO and Kelvin waves when we filter for rainfall or outgoing long wave radiation. No one's ever really looked at the spectral power in wind, and you don't see a spectral power gap in wind between the Kelvin wave and MJO. That's why I've abandoned looking at tropical wave diagnostics when I'm caring about MJO and Kelvin waves. When looking at I've abandoned OLR and rainfall products when filtering because there's a gap there and it causes issues in understanding where things are. But if you look at the upper level winds, like what I'm showing here, this is 200 millibar velocity potential anomalies. Velocity potential could be a scary word. It just represents like when air is moving apart or coming together. And if we look at 200 millibars, we're looking at like upper level divergence or upper level convergence. It's essentially what it is. You don't get that gap in spectral power. So in my professional opinion, the Kelvin wave and MJO are the same thing. We're just confused in our field of meteorology that where we say that they're different. And it's going to take many years for this to kind of come to fruition where people will accept that the MJO is actually a Kelvin wave. I'm not in academia anymore. I'm in the private sector, right? I work for Weather Channel, your Weather Channel platforms, weather.com, which is now owned by IBM. I'm not working on this problem and trying to sway the opinions of the folks in the field anymore. I've done this with Kelvin waves and trying to relate Kelvin waves to Atlantic hurricanes. I haven't really thought about doing this much in this MJO Kelvin wave realm, but there are people in the field that are trying to do this. So hopefully with time you'll have more clarity on the subject between what's the difference between Kelvin waves and MJO. The one thing that's interesting, right? No one has ever proved that the MJO actually exists. There's no set of equations to prove it. But there are a set of equations that proves Kelvin waves, right? You go back to Matsuno's paper in 1966, the shallow water model. So these are things that do exist, and we can have mathematical equations. So I see another question from Ador here. Is the plot we were watching the standing wave over favorable phase for hurricane season? Now that we're seeing the standing wave, will that affect the MJO? So I did switch plots on you, but yes, the standing wave is over the Indian Ocean and African continent. That is a favorable location for Atlantic hurricanes. And what happens when the MJO passes this point in the world, when the MJO passes the location where the standing wave is present, you'll see a much higher amplitude in the MJO. Like you can see this here as the black dash contours really pile on. You see the purples start to highlight where the MJO is when it passes the African Indian Ocean continent, because that's where the standing wave is. And what happens here is something called constructive interference. It's essentially when the MJO is coming through, you have a standing wave, and then all of a sudden you add them together and you get amplification. When you have the opposite happen, when you have the suppressed phase of the MJO move across the location where the standing wave is, you call it destructive interference. And typically what happens with those destructive interference events is when the suppressed phase MJO moves across the location where the standing wave is, it shuts it down for a period of weakened time. But then as soon as the next active MJO comes through, there you get that amplification again. So good questions there. We call this destructive and constructive interference. How will the MJO and Kelvin wave affect atmosphere or the hurricanes? So when the MJO passes the Atlantic Basin and the Indian and the African continent, we typically see during the time of year, we often see the atmosphere moisten. We often see wind shear reduce. So the upper level easterly wind shear of the MJO counters the westerly wind shear of the western subtropical Atlantic. And this actually helps ventilation of convection as the MJO passes Africa. It can enhance your African easterly wave activity that then moves back off. These easterly waves pump off Africa and move back into a more favorable environment for developing tropical cyclones. And there's also something a little bit more sciencey. When you have a low-level westerly wind anomaly associated with the MJO active phase, it actually helps enhance the background vorticity, the cyclonic vorticity, which is essentially just the spin of the atmosphere. And that background spin allows for these waves to kind of move into a more favorable environment and then kind of spin up because that enhanced background vorticity is there. So that's a good question. Hey, Alan Snyder, thanks so much for the bits, bud. Appreciate it. Thanks for joining the stream and joining the weather session here. These are all good questions that you guys are asking. And these are all things that have been, not really talked about much in the media mainstream, right? People, when I first started at the Weather Channel, if you were going to say something, like wind shear or an MJ or a Kelvin wave, they were going to kill you if you said that on air. But we're seeing a shift in the way that the media thinks about these things, and I think that there's a real opportunity here for educational purposes, right? To talk about these things, right? We have the diagnostics coming online now. I'm not the only person building these diagnostics anymore. There's a whole slate of very smart meteorologists that are making these products available on their websites that they host for free. And you can track these waves in real time. It's cool, man. This stuff didn't exist when I was in grad school. So I'm glad that people are finding interest in them because they really help explain these fluctuations in our Atlantic hurricane seasons that are important. So, hey, Jabron, I see you had a question here. Would you say the Saharan air layer was more prominent this year compared to other years? Yeah, so, I mean, if you live in Puerto Rico, you will believe that the Saharan air layer was more prominent this year than other years, and that was because we saw a tremendous Saharan air layer outbreak across the tropical Atlantic basin that just pretty much blacked out the sun. It was a ton of dry air, dusty conditions that pushed across Africa and into the out across the Atlantic basin. That actually made it into the U.S. It was remarkable dry air. Now that being said, I haven't seen any diagnostics that said that the frequency of Saharan air layers was more this year compared to other years. I did see that the amplitude of this event making it across Puerto Rico was a top 3 strong event. I don't know if it was a record strong event, but it was a top 3 strong event. So I think that we need to be careful when we look at when people are saying that the Saharan air layer, which is this dusty dry air that gets pushed off Africa, is more prevalent this year. I think we have to be careful because we haven't seen those statistics on if it's more frequent this year or not. And I don't think it is. It's here every year. We just we often see the Saharan air layer giving different times of the year, usually most prevalent in the early summer months. We always see it. And there's a lot of research, there's been research back into the 70s and 80s that talks about the Saharan air layer and its role on developing Atlantic hurricanes. And there was research campaigns that I was a part of. One was NASA's HS3 campaign where we were flying Global Hawks into hurricanes over the Atlantic Basin. I think this was, it may have been 2010, somewhere in the 2010, 11, 12 range. I have a bad memory. But whatever the season that we had a Hurricane Nadine, because we pretty much sampled that storm to death. But that was the year that we did this HS3 campaign. It may have been a year later after that too. But one of the PIs on that was essentially Scott Braun, Dr. Scott Braun of NASA, and he was really interested in trying to understand how these Saharan air layer environments interact with developing tropical cyclones. And I think one of the concluding factors of that research was that when there's shear imposed on a tropical cyclone in an environment of Saharan air layer, then the Saharan layer, so that Saharan air layer can get ingested into the tropical cyclone and cause the tropical cyclone to sputter out, maybe decouple from convection. But if there is no shear in the vicinity of the tropical cyclone, then the Saharan air layer can never make it into there. Hey, Budget Wonk 623, Colin, thanks so much for the subscription there. I appreciate it. Colin is also one of my fantasy football weather guys, Budget Wonk, in the chat. So appreciate that. For those interested in fantasy football and weather, we do have a Twitch stream every 8 p.m. on Fridays now that you guys can come to and ask your questions about fantasy football and weather. And we also give a weather briefing. So if you guys like weather, there's another show to watch. So anyway, good question about the Saharan air layer. I appreciate it. And that's still a developing thing that the media is starting to pick up on now. And you'll probably hear more about it, which kind of adds to confusion in my opinion. So, but good question. And Alan, I appreciate the kind words there. And then I, tracking hurricanes, I did it as a kid. I remember, actually I wanted to be a veterinarian before I became a meteorologist. I volunteered a year in a vet's office. This was in high school. And, I was the guy that pretty much held the animals down during the meetings. And I actually held a lot of dogs when they were put to sleep. And I did not like that aspect of the job. It was not something that I enjoyed. And I would always go home and watch Jim Cantori on the Weather Channel talking about hurricanes in the summertime. And I remember, why am I doing this thing that I don't like doing? Why am I pursuing this career when I can go to school and talk about weather, understand, how meteorology works? It's still a new field. It's, I love watching thunderstorms hitting, watching hurricanes. Don't want to see them hit anywhere. But, as a kid, one hit us, Hurricane Bob in 1991, and it's kind of sparked my passion ever since. So I'm right there with you with the passion of understanding these powerful weather systems, these hurricanes. Do I think the rest of the season will stay quiet or the rest of September? Okay, let's get into this September question because this is something that I wanted to get to because it's something that the models are indicating here as a possible risk for the late September timeframe. This is from Levi Cohen's Tropical Tidbits sites, the graphics here. This is the GFS model, and this is what I've seen being shared on social media a number of times, talking about hurricanes possibly spinning up here over the Western Caribbean. The models have been volatile with this possible tropical cyclone. And we're looking out past hour 240. And the one thing that I did a tweet I think yesterday. I'm saying, hey, listen, when you get out into the 11 to 15 day forecast of the GFS, there is a known bias that the model during specific times of year can, try to spin up a hurricane in this part of the world. And we often see this kind of what we're looking at here is like precipitation in the green shading with the contours or pressure. And you see a lot of precipitation here over the Western Caribbean. This is hour 228. As you move into hour 240 into the later parts of the GFS, the resolution gets a little bit worse, and we now the model is trying to spin up this tropical cyclone immediately and then track it towards Florida. Guys, I'm a bit skeptical. I was skeptical of this. I still am skeptical of this model progression. But there is some things that, I'm taking a step back and trying to understand what the models are doing to see what's going on here. And there is a very amplified upper level feature here. As I go into the medium range forecast here, hour 180 plus, the models are showing, we're looking at a 500 millibor height anomaly pattern here. They're showing a massive ridge over Western Canada and a bowling ball of vorticity, upper level vorticity. This is a deep upper level trough that's digging down across the Great Lakes into the eastern U.S. This is a really good pattern to facilitate an early season cold wave across parts of the plains and down across the Midwest, and eventually it'll make it in the eastern U.S. here. But this is a very amplified pattern that this model actually digs this upper level trough all the way down into the deep southeastern U.S. states, into the Gulf of Mexico. And why is this something that I'm interested in? Well, I'm going to change my view, head out to my playpen of weather information here, and show you a hurricane slash upper level wind stream diagnostic that I've developed. And I'm going to go out to hour 240 here. This is probably good here, 234. When you get this upper level trough that digs across the eastern U.S., this is the U.S. here, by the way. So wherever you see these like grayish contours, here's Florida. You can kind of see this is all landmass. The blue, green, yellow, orange, red shading is the upper level wind speed at 250 millibar jet stream. So we're looking at the upper level jet stream. And the black contours are pressure, right? This is a pattern that's setting up in the eastern U.S. and Gulf of Mexico, Caribbean Sea that indicates that there's going to be a jet stream setting up over the Gulf of Mexico because of all that cold air that's coming down across the eastern U.S. down to the deep south. There should be a pretty good cold front here. Anytime you get a cold front, that enhances your jet at the upper level feature, and you're getting this jet streak right over the southern Gulf of Mexico or the Western Caribbean. That is essentially the right entrance region to this jet stream, where you can really see it amplified over the eastern U.S. and Atlantic Basin as you get into the northern side of this Mid-Atlantic ridge. But whenever you get whenever you get the jet entrance region on the right side of the jet streak, that's where essentially the atmosphere is forcing for vertical ascent. You go through these things called the QG forcing equations, the QG vector equations, and one of those types of forcing mechanisms is the right jet entrance, and this is right where the models are kind of trying to spin up a storm past hour 240. So this is something that I'm interested in now. Like I don't think that you can say there's going to be a new storm coming in the late September or early October timeframe, but if you get this big upper level trough and big cold front over the eastern U.S., you're going to get this jet stream that then moves into a preferable location for maybe some forcing for vertical ascent over the Caribbean Sea. And if we look at the models here after hour 240, this is where they're kind of spinning up the storm right in that right jet entrance region, and you can kind of see that. So I think this is still a little overdone, but I'm a little bit more interested in it. I'm not going to say that there is going to be a storm developing here. I'm still worried that the models are going to have to resolve that upper level trough over the eastern U.S. You get this big amplified pattern. If the models back away from the ridge over Western Canada, it's going to reduce the amplitude in the southern extent of this eastern U.S. trough, which then changes the jet stream location. So maybe it moves it away from the Caribbean Sea and maybe more towards the central Gulf of Mexico or maybe over Florida. So I'm not sure yet if we're going to see this storm spin up, but there's a risk here, right? We're going to have to pay attention to this particular pattern here that we're looking in the models, because this is what's probably aiding in the genesis of that possible Western Caribbean storm. So, but this is, a piece of bad news also for the Western U.S. wildfires, right? You see this big high amplitude ridge. I'm going to change this plot here from 500 millibar geopotential height anomalies to 500 millibar geopotential heights and just show the actual field. And take a look at the subtropical ridge over the western U.S. Pretty much a 591 decameter ridge extends from southern Texas, the Mexico, northern half of Mexico, all the way up to British Columbia. This is a very high amplitude major western U.S. ridge that's setting up, which is the reason why we're seeing such a robust cold air mass come down across the Great Lakes here. But this is a very dry and hot pattern that sets up under this ridge, and this is not good for forest fires out in the western U.S. But this particular pattern is also aiding in the genesis of that storm in the Caribbean. And whenever you get these forecasts out past hour 120, there's going to be some model volatility. And anytime you have model volatility, you change the amplitude of the ridge in the west, the trough in the east. It could change the tropical forecast over the western Caribbean. So I'm not real bullish yet on another developing storm like the GFS is showing here. And I do see that the 12Z run might be out here. I haven't looked at the 12Z GFS. Let's see if it's updated in Tropical Tidbits. So we can take a look at that. Let it load up here, but you can see how there is that cold front. You can actually see the cold air pushing down all across the Mexican plateau on the eastern side here. In the pressure contours, you can see that actually happen, which is pretty cool here. And you can actually see the enhancement of rainfall on that leading edge there. But as it gets down to into the Caribbean Sea there, we're looking at hour 234 now. This is right where the model was trying to develop that storm right over the Western Caribbean here, and it's not doing that anymore, right? And actually, we have to wait a bit further in time for it actually even to kind of spin up something. Now we're looking at hour 288, 294. So this is what I'm talking about, volatility in the model. If I bring up the latest GFS here and take a look at the 500 millibar G potential height difference plot, I bet you're going to see some pretty big changes in the western U.S. ridge or the eastern U.S. trough. Let this load up here. This is on 0Z, and let me load to 12Z, and then go to the difference plot here and show you. Yeah, so there you go. This is what I'm a little afraid about here. Take a look at how the GFS has changed the actual configuration of heights. It's gotten way more aggressive with the ridge over the northeastern Pacific. It now kind of digs this upper level trough down across the plains and almost shows like a cutoff risk here as you move in the model. You see the ridge is no longer the trough in the eastern U.S. is no longer as highly amplified as it was predicted in the 0Z run. And this is probably why we're seeing the discrepancy down in the tropics now in the Caribbean Sea, because it's changing that eastern U.S. ridge and it's making it more of this like cutoff feature over the Rockies again. And we saw this again. Remember, we had that big upper level trough that impacted the Denver region, where we saw like high temperatures, 100°F, go to snow in the Denver region. This kind of looks like a similar evolution towards that. So this is what I'm afraid about, the model volatility. It's going to impact the possible progression of that or genesis of that Caribbean storm in the 10 to 15 day period. So that's why we're going to have to pay attention to the models as it predicts and resolves this mid-latitude pattern. Because, right now you get down to the medium range and you're going to see changes in the extratropical pattern. Alan, do you have to worry about something cutting through Florida? You live in St. Lucie, Florida. No, I don't think so yet. You don't have to worry about anything hitting Florida at this point in time. I do think that we're going to have to pay attention, though, as the season goes on. And I'm really saying you should really be paying attention to the latter half of October, because I do think we're going to move into another intraseasonal state that we see future hurricanes develop over the Atlantic Basin. But this is an interesting change, and something that I was monitoring out in the Pacific Basin, what might be causing the models to have a hard time with resolving the U.S. pattern is because of what's going on in the West Pacific and some of the tropical forcing out there. The models, this is the ECMWF operational run from 0Z, the high-res run from 0Z today. We're again looking at our mean sea level pressure maps with the contours here. Are the pressure. You ever see the circle here? That's essentially like a tropical cyclone in the West Pac. Here's an East Pac tropical cyclone. This blue and green and orange shading is essentially the jet stream at 250 millibars. The vectors are essentially the irrotational winds, and then these gray shadings are essentially moisture. It's the total column water vapor moisture. And the models are showing a West Pac it's probably a typhoon at this point, but they're showing a typhoon out there in the West Pac over the next 60 hours, and it's lifting. The models are lifting this disturbance up. You know how the vectors to really start to get going here. You can see all the vectors pointing away from the actual typhoon, and you see the jet streak starting to develop over the Western Pacific. That's essentially the upper level heat transport from this West Pac typhoon on the jet stream on the Pacific jet stream here on the western side of the basin. And as you move it forward now, you can see how the model starts to extratropically transition this West Pacific tropical cyclone, and we start to see an interaction with the jet stream where the jet stream becomes really amplified here. And this is why we're starting to see the western U.S. ridge develop in the medium range and dig down that trough over the eastern U.S. that then leads to this highly amplified pattern that we just talked about in the ECMWF forecast that is potentially aiding in the genesis of that West Caribbean storm. So the models are going to have to resolve this typhoon Pacific jet interaction correctly to really understand what's going to happen over Western North America and how high amplitude that ridge gets, where the ridge axis sets up, how it interacts with the downstream trough and digs that trough across the Great Lakes down into the eastern U.S., and whether or not that pattern is sustainable to really dig that trough down deep into the the southeastern U.S. and Gulf of Mexico to enhance that jet stream over the Gulf of Mexico, Caribbean Sea, and put that right entrance region right over the Western Caribbean, like the GFS was showing, over those cycles where it develops that storm down there in early October. So these are all the things that we have to pay attention to when we're looking at tropical cyclogenesis events out in the medium range, and how those events can be, they can change. And this is why I'm skeptical on that GFS solution of a hurricane in the Caribbean Sea or Gulf of Mexico as we move into that 11 to 15 day period. There is a risk of it happening. It's more of a non-zero threat than I thought it was yesterday, but I'm still interested in see how the models resolve this typhoon North Pac jet interaction, because it's going to spark off this chain of events that can really amplify the pattern across North America, which then aids in that jet streak development over the Caribbean Sea. So things we're going to pay attention to, guys. But it's interesting how the GFS has backed off of the big western U.S. ridge, eastern U.S. trough, and it's kind of trended to more of this cutoff feature over the southwestern U.S. I mean, take a look at that. That's a huge change in the model, and that's why we're seeing all the rising heights across the eastern U.S. And this just screams to me another possible record warm Denver type of experience to snow again. Now, this type of pattern, this forecast is kind of very similar to that, that progression, at least in the 12Z GFS. So anyway, guys, it's an interesting time, right? And I guess the main take-home point here, guys, as we get close to the top of the hour here, is that I think we're going to be in an interseasonal low hurricane activity. I think that things are going to be a little quiet here next 1 week, potentially 2 weeks. I'm not sold yet on the Western Caribbean tropical cyclone, but it doesn't mean that this is going to be the end of the hurricane season. I'm seeing things in the models that we're going to get another window that's favorable or conducive for Atlantic hurricanes. That window should start to manifest at some point, maybe in the second week of October, and it's going to continue probably all the way through all of October. So as you move into the latter half of the hurricane season, the storms start to, form closer to the U.S., the Caribbean Sea, and the Gulf of Mexico are locations that we have to watch for developing hurricanes. If you think about the genesis of Hurricane Sandy, Sandy developed over the Western Caribbean, and it developed in a similar MJO passage that we're looking at in maybe in the middle, the second week of October. If you go to the national, actually, you know what? If I can share my screen one last time here, and show the National Hurricane Center archive here. There's an archive. You can go to Tropical Cyclone Reports. We gotta make sure we're on the Atlantic Basin. We'll go to 2000. Guys, chat. When was Sandy? Because I'm drawing a blank on when Hurricane Sandy was. There we go. Hurricane Sandy was 2012. Thanks, Tree Cutter. I appreciate that. You go down to the report here and look at their first image. Come on. That's a big report, guys. It's a lot of information here. If you guys were impacted by Hurricane Sandy or had anyone family impacted there, there's some tables and statistics on here. Wow, this is a long report. What are we at? Page 42. I didn't realize it was this long. Oh, here we go. We're getting into the images now. Here we go. Okay, figure 1. Actually, I built this figure for the report here, but we're looking at 200 millibar velocity potential anomalies with the red contours representing the active or suppressed phase of the MJO. The active MJO is dash contours, and we had an active MJO pass. We're essentially looking at the Pacific and African continent here. It actually goes out to the Indian Ocean here, sorry. But this is the Atlantic Basin pretty much over the maybe left side or central side of this image. And as this active MJO came through, we saw the development of Sandy. And this was late October, October 22nd. So these active MJO events can help spawn these hurricanes over the Caribbean Sea that can be impactful. And this was a strong hurricane. So we got to pay attention to these types of evolutions here as we move into that latter half of October, because I'm seeing signs for the same type of intraseasonal state to kind of evolve. And I think it's something that we still have to pay attention to. So that's the take-home message, guys. We We have a little bit of a lull in the season right now. We have another window of opportunity in the latter half of October. Guys, it is 1 o'clock on the dot. I appreciate everyone joining the stream and asking all the questions. I'm still a little bit unsure about next week if I'm going to have a stream or not. There's some things going on that are still in the up in the air in my personal life. But these, if I'm around, I'll be here and I'll do another stream. We'll be able to kind of open up this and kind of nerd out some more because we're going to move into another active period, and I want to cover that as much as I can. So, guys, I'm Doc V. You can follow me at MJ Ventures on Twitter. I appreciate you joining the stream, and I hope all you guys have a good rest of your Wednesday hump day. See you guys.